everyone. In yesterday's lecture, I had started exercise 2.2, question number 1. In question number 1, 6 parts were there, and out of those, we have solved 3 of the parts. Now, you had to solve 3 remaining parts of the question. I hope you have done it. Now, question number 2. We are going to start question number 2. Only 2 questions are there in the exercise. Question is, find a quadratic polynomial each with the given numbers as the sum and the product of its zeros. Means in the question we are given 2 numbers. The first number is the sum of zeros and the second number is the product of zeros. With the help of these 2 numbers, we have to find the quadratic polynomial. 2 methods are to solve the question. I am giving both the methods and I'll tell you when to apply which method. The first one is the very simple method. I am just going to tell you. Here in first part, S is given. S is equal to, S stands for sum of zeros. S is equal to 1 upon 4 and P is equal to minus 1, where P stands for product of zeros. Now, the first method is direct method of finding the quadratic polynomial. Direct method, when to apply direct method? Whenever you are given a question to find the polynomial and you have to use that obtained polynomial further in the question, means you have to proceed the question further using that polynomial, then you can use direct method. Means suppose you are given sum is 1 upon 4, product is minus 1, and you have to find the polynomial and that polynomial is further used for the question, then you can use direct method. What is direct method? Let's see. We write like this: required polynomial is k times of x square minus sx plus p. This is direct method. We can use direct method. Here k is some constant, s stands for the sum of zeros and p stands for product of zeros. What is the value of k? K is constant. What is the value of k? The value of k is equal to the LCM of the bracket. Whatever the terms found in the bracket, the LCM of that bracket is equal to k. Means we have to multiply by that LCM to the whole polynomial and we'll remove k. Let's see how to solve. K is times of x square minus 1 upon 4 in plus of sum of zeros into x plus minus 1. Now, what is LCM in the bracket? LCM is 4. Means we have to multiply the whole polynomial by 4 and we can remove k. We can write here where k is constant and is equal to the LCM of the bracket. Now here LCM of the bracket is 4. So what we do? We multiply the whole bracket by 4. What is the result? We have 4x square minus x minus 4. This is required polynomial. This is required polynomial. 4x square minus x plus 4. This is the first method. Using first method, we can find out the result. Now, second method. When to use the second method? Second method we use only when you are given the sum and product of the zeros and you have to find the zeros, the polynomial only. and that polynomial is your exact answer, accurate answer. Means that is the exact answer to be obtained, like find the quadratic polynomial. So in that case, you will use the second method. I am writing here C, second method. In second method, we will assume a general polynomial. Let polynomial be ax square plus bx plus c and a is not equal to 0. General polynomial. Now you have been taught about the sum and the product of zeros. So what is sum? S is equal to minus b upon a, and S stands for sum of zeros, and sum of zeros is given 1 upon 4. This is 1 upon 4 is equal to minus b upon a. Now we compare both sides with numerator and denominator with denominator. So what we have, a is equal to 4 and b is equal to minus 1. Now we have got the value of a and b. Let's see, p is equal to c upon a, and p is given minus 1. Minus 1 is equal to c upon a is 4. So by cross multiplication, we have c is equal to minus 4. So we have got the values of a, b and c. Now required polynomial is, just we have to put the value of a, b and c in this polynomial, in this assumed polynomial. Like a is equal to 4, so this is 4x square. Now b is equal to minus 1, so minus 1x, 1 is not written there, and c is equal to minus 4, c is equal to minus 4. This is how we obtained the answer. So we have given two methods. One is direct method and other is indirect method. When to use the direct method? Direct method we use only when you have to find the polynomial and the polynomial is used further for the next level. Means the question is proceed further. Then you can use direct method. Otherwise, if you are given to find the quadratic polynomial, that is enough your answer. So you will use this method. So I have done the first part. Let's see some more parts, and after that whatever the parts I will left, so you have to solve those problems yourself. Let's see. I am solving. I am taking this second part, or you may take the third part. Here 0 is given. I am solving the third one. See, here the first number is given sum and second number is product. So you are given s is equal to 0 and p is equal to under root 5. Just I am using the second method because you are given find a quadratic polynomial. So I am using second method. So let's see, s is equal to minus b upon a, and s is given 0 upon 1 is equal to minus b upon a. You know that a is not equal to 0. So compare this. What we have, a is equal to 1, b is equal to 0. Let's find the value of c using p is equal to c upon a, and product is given root 5 is equal to c upon 1. So c is equal to root 5. So we have got a is equal to 1, b is equal to 0 and c is equal to root 5. So required polynomial is ax square plus bx plus c. A is 1, so we have 1x square, b is 0, so plus 0x plus c is root 5. 0x means nothing, So you can write like this, or you can write this x square plus root 5 is your required answer. So I have taken the third one. You may take one more part. I am taking fifth part. Fifth part. Let required polynomial be ax square plus bx plus c and a is not equal to 0. So here in fifth part, s is equal to given minus 1 upon 4 and p is given 1 upon 4. Using this formula, s is equal to minus b upon a. This is minus 1 upon 4 is equal to minus b upon a. Minus and minus cancelled. A is equal to 4 and b is equal to 1. Using product, p is equal to c upon a. So 1 upon 4 is equal to c upon a is equal to 4. This 4 and 4 will go. What is the value of c? C is equal to 1. So we have got a is equal to 4, b is equal to 1 and c is equal to 1. So what is required polynomial? Required polynomial is ax square plus bx plus c. A is equal to 4, so 4x square. B is 1, so plus 1x, and c is equal to 1 plus 1. So this is your required answer. So this is how we find the solution of the given question. In the question, 6 parts were there. I have solved 3 of the parts, like first part, third part and fifth part. Remaining 3 parts you have to try yourself. Now in first part I have used 2 methods. First one is direct method and this is indirect method. So for the remaining question you will use the second method, not the first one. Second method I will show in further questions. Okay. Now division algorithm for the polynomials. What is this? Means we will be given 2 polynomials and one of them is the dividend and other is divisor. I think you remember this. Px is equal to qx into some quotient plus rx. What is means? If we divide one of the polynomials by other, we will have some quotient and remainder. We have to use long division method and we have to verify whether our division is exactly accurate or not. So we will put the value in this one like qx quotient into divisor plus remainder. It must be equal to the dividend. Let's see, here we are given px is a polynomial, qx is another polynomial. Its degree, the degree of px is more than that of qx. Of course, this px is what? Px is dividend and qx is divisor. So we have to use long division method. For the process and we will verify algorithm stepwise procedure. Algorithm means stepwise procedure. So we have to show stepwise procedure of division. Let's see how to solve this question. This px is dividend. So we are going to divide 3x cube plus x square plus 2x plus 5 is dividend. And divisor is x square plus 2x plus 1. What is the method of division? We continue the process of division until the degree of remainder must be less than that of degree of divisor. you have to keep in mind. So it has been taught in class 8 and class 9, so you are aware about the method. This 3x cube, what is the method of division? Every time what we do, we try to eliminate the first term of dividend. First term of dividend. And if we are going to divide this first term of dividend, this is 3x cube. 3x cube can be divided the first term. Here with the first term we have x square. Means 3x cube divided by x square, we will get 3x. Means 3x times we can divide this. So let's see how to divide. This is 3x times. 3x times. Now we multiply this 3x to divisor and we put the value according to their degree. Means like term. 3x into x square, we have 3x cube. 3x into 2x, we have plus 6x square. 3x into plus 1 plus 3x. See, I have put the values according to their degrees or with like terms. X cube, x square and x. What we do next? We subtract this. In case of subtraction, we change the sign. Here we have minus, minus and minus. The first one will go. What we have left? 6x square negative plus x square positive. We have minus 5x square. Here plus 2x minus 3x minus x. The next term plus 5 is left. Now we have here degree is x square. Here degree is x square of this one. How many times we can divide? Minus 5 times. So minus 5 times. Minus 5 into x square, we have minus 5x square. Minus 5 into plus 2x minus 10x and minus 5 into plus 1 minus 5. So change the sign. This is plus, plus and plus. This will go 10x minus x 9x and plus 5 plus 5 plus 10. Now see, we see that degree of remainder, this is remainder, is now 1 and degree of divisor is 2. Means we have degree of remainder is less than that of degree of divisor. So we cannot proceed further. It means clearly this is remainder. Remainder is 9x plus 10. Now algorithm. We have to verify. Whether this quotient into remainder, quotient into divisor plus remainder is equal to dividend or not. Dividend or not. So if it is found, it means your solution is correct. Let's see. We multiply this. I am checking it. Qx into q, that is divisor into quotient. We have x square plus 2x plus 5 plus 2 plus 1 multiplied by 3x minus 5. 3x minus 5. Let's see how to multiply. We start with the first term and multiply in all the terms. With second term multiply in all the terms. Let's see. 3x into x square, we have 3x cube. 3x into plus 2x plus 6x square. 3x into plus 1 plus 3x. Now multiply this by minus 5. Minus 5 into x square minus 5x square. So here we have minus 5x square minus 5 into 2x means minus 10x. So minus 10x minus 5 into 1, this is minus 5. Add this. As you multiply the numbers, so we have 3x cube plus 6x square plus 3x. It is 3x cube, 6x square minus 5x square is x square, and here 3x and minus 10x. We have minus 7x and minus 5. This is the result of product of quotient and divisor. Now plus remainder. Plus remainder. Remainder what we have? 9x plus 10. So we have 9x plus 10. Add this. What we have? Add this. So we have 3x cube plus x square plus 2x 10 minus 5 plus 5, which is equal to dividend. Means our procedure is our method and solution is correct. What we have got, 3x cube plus x square plus 2x plus 5, which is equal to dividend. Now one more thing I would like to add regarding this question. Sometimes you are asked what must be subtracted to the given polynomial so that it can be exactly divisible by x square plus 2x plus 1. I am adding another question to this, removing this one. Question can be added, what must be subtracted and what must be added. What must be subtracted from the polynomial 3x cube plus x square plus 2x plus 5 so that it can be exactly divisible by x square plus 2x plus 1. I am giving one example. If I am telling you what must be subtracted from 21 so that it can be divided by 4 exactly. Try to understand. Question is, what must be subtracted from 21 so that it can be divided by 4 exactly. So simply what will do? You divide 21 by 4. 4 5s are 21. What is remainder? Remainder is 1. Means if you subtract 1 from 21, you can divide the remainder by 4 exactly. The same thing happens in this case also. The question is, what must be subtracted to the polynomial 3x cube plus x square plus 2x minus 5 plus 5 so that it can be divided by 2x square x square plus 2x plus 1 exactly. So whatever the remainder is, the same must be subtracted. So 9x plus 10 must be subtracted from the polynomial so that it can be subtracted, it can be divided by x square plus 2x plus 1 exactly. The same question, what must be added? I am telling you, what must be added to 21? Try to understand. What must be added to 21 so that it can be divided by 4 exactly? So what you do? You do the divide. 4 5s are 20. Or you can try one more time. 4 6 are 24. 4 6 are 24. And if the number is divided by the given number exactly, the remainder must be 0. Remainder must be 0. So 4 6 are 24, but your number is 21. What is exceeding? 3 is exceeding. So what to do? You will subtract 3. 3 means minus 3 means you will add minus 3, or you can say 0 minus that number. So what is the case? What must be added to this polynomial 3x cube plus x square plus 2x plus 5 so that it can be divided by polynomial x square plus 2x plus 1 exactly. I had shown what must be subtracted. So whatever remainder is there, that must be subtracted. In case of addition, what must be added? So to divide the number exactly, remainder must be 0. So what to do? You will write simply like this: number to be added is 0 minus remainder. 0 minus remainder. This is the method. 0 minus remainder. I am writing in full. 0 minus remainder. So in this question, if you are asked what must be added to the polynomial 3x cube plus x square plus 2x plus 5 so that it can be divided by x square plus 2x plus 1 exactly. So whatever remainder comes, we subtract the remainder from 0. So it is 0 minus 9x plus 10, whatever remainder is. So your answer is minus 9x plus 10. See it. If you minus 9x minus 10, See, if you add minus 9x minus 10 to this remainder, what will be the remainder now? Remainder becomes 0. And in what case remainder becomes 0? Remainder becomes 0 only when the polynomial is divisible by the other polynomial exactly. So your answer is minus 9x plus 10 for this question. So you can practice some more question like this. In our next lecture, we'll show the this kind of question again. I'll give some more question in the next lecture for you. So you can practice some more question. Okay. Thank you very much.